Okay, so we did not get our notes in last class. This is for B Algebra 2. What we're doing right now is we are learning how to evaluate simple logarithmic functions. So first of all, what is a log? The best way to look at this is, let's look at this situation. If I have 2 squared, we know that's 4. 2 cubed is 8, right? 2 times 2 times 2 is 8. The question then becomes, what if the answer is 6? What would the exponent be if my answer was 6? 2 to the x is what? We want it to be 6. There's got to be something that raises 2 to, and then you get 6 for an answer. That's what logs do. How can we determine what x is? It is the logarithmic operation of exponentials. So let's talk about inverses, because we are learning about a special inverse. Oops. Okay, so we're drawing a little bridge map. What inverses do we know? Well, we know that if we add, the inverse of that would be subtraction. If we multiply, the inverse of that would be division. We know that if we have x squared, the inverse of that would be the square root of x, or x to the 1/2. So what if we had x cubed? What would the inverse be? Well, that would be the cube root of x, or x to the 1/3. Well, what we're going to find is that when we have exponential functions, the inverse of exponential, so some number to the x, is the logarithmic function, the log base 2 of a number, okay? Log base 2 of x. These are actual inverses. So let me give you the definition in an equation. The logarithm of y with base b. We say this, the log base b of y is equal to x. If this is true, then this is true. Then, let me put it in a different color. Then, we're going to use the loop method. Then b to the x equals y. If this is true, then this is true. And if this is true, then this is also true. Okay? So, what is the logarithm? The log is the number that a base, some number base, can be raised to obtain a certain, and I'm going to call it y value. Seems a little bit fuzzy, but this is what you want to remember right here. This is the definition. By definition, this is what a log is. Okay? So let's look at some examples. And we can, if this is true, then what else is true? This is called the loop method. If this is true, and it is because it says it's equal, then 3b to the x equals, b to the x, b to the x equals y. Is that true? Yes. 9 does equal 9. Check. Now, again, if this is true, then this is true. 8 to the 0 equals 1. 1 equals 1. Check, because anything to the 0 power is 1. And here we have 5 to the negative 2 is equal to 1 over 25. Is this true? Well, yes, because what did negative exponents do? They take the entire value there and put it in a denominator. 5 to the negative 2 is equal to 1 over 5 to the positive 2, right? Because we know that x to the negative 2 is equal to 1 over x squared. So that is in fact true. Okay, let's flip over the page. I want you to stop the tape for a moment and do these two problems, okay? So stop it, try it, come back. So your answer should be, and those are what you should have gotten. All right, let's go on. Now we can evaluate using our definition. And you could do it one of two ways. You can set this equal to x and then rewrite the equation like we've been doing. 4 to the x to the what? 4 to the what equals 64? That is the evaluation of this piece of the log. 4 to what power is 64? Well, that would be x would be 3. So that means that log base 4 of 64 is 3. Let's test that out on our calculator. So when you want to do this on your calculator, and most of your calculators have this function. If it doesn't, I'll show you another way to do it, but hit the math button and then scroll up twice. It's hard to see a little bit in this light, but and then you hit the log base function and you see that it gives you places to put the base, which in our case is 4. Move over with your arrow key and put 64. And what do you get? That is exactly what we expected, 3. All right, so math, scroll up twice, enter log base 4 of 64 is 3. All right, so this evaluation is 2 to what power equals 1/8? 2 to what equals 1/8? Well, I know it's going to be a negative. And then what 2 to what power is 8? 3. So x is negative 3. 32 to what power is 2? Well, now here, we're not taking a quantity and putting it in the denominator, but we are going from a larger number to a smaller number. And when this occurs, we know that x is some fraction. X is a fraction because we're taking the root. It's like the what root of 32 is 2? Well, 2 to what power is 32? The 5th. So x is equal to 1/5. Let me show you another problem like that. If I have the square root of 36, we know is 6, right? So that's 36 to the 1/2 is 6. Well, the way I would write that in logs is that, I'll get a different color. The log base 36 of 6 is what? Okay, and here we have 36 to the x equals 6. 36 to what? Well, the answer to that is 1/2. The square root, or the 36 to the 1/2 is 6. Okay, so that answer is 1/2. When you're going from a larger number to a smaller number, your answer is a fraction. All right, I want you to try these examples, 1, 2, and 3 down here. Okay, and then do that, stop the tape, and see how you do. All right, your answers should be, so hopefully you stopped the tape, 3, -4, and 1/2. Okay, did you get those answers? If not, look at the examples above and see where you went off. Okay, 2 types of logs. We have a common log, which is a log with a base of 10. And it's so common, it's on your calculator right here next to the 7. And if you see a question that says, what is the log of 62? If it's so common that if the base number is missing, and that is missing here, then it is 10. Just like we know that if we have x squared, we know what a in front of x squared is. If it's not written, it's 1. If you have a log and there's nothing here, then it's 10, the common log, because we live in base 10, right? We have the 1s and the 10s and the 100s, and so we live in base 10, and that's why it's so common. Now the natural log is a log with a base of e. We discussed e the other day and where it comes from with compounding interest. Let me just write it out for you. If you have the log base e of 6, this is an equivalent statement to the natural log of 6. And that is also on your calculator. Okay? The natural log button is right below the log button, and it's right there. So you could take the natural log of 6. Okay? And we need to do that lower on the page, so let's do that. So you just hit the natural log button. And so when you're evaluating a question like this, the natural log of 6 is what? 1.792. All right, let's do this one. We'll do these two, you do these two. So if I have the log, what is it? It's really the log base 10 of 3.2. 10 to what power is 3.2? So I take the log, I hit the log button of 3.2, and I get 0.505. So the answer to this is 0.505. Okay? Now I want you to use your calculator and do these two problems. Okay? All right. Now that is it for the notes. I do want to, because we missed this as well, the algebra warm-up today, let's look at this. So if you got this done, I want you to look at how you did. This is where we use an exponential formula. They've given us most things, and we just have to solve for one thing, okay? And we just plug and chug here. This is the initial amount, a to the 0. This is the rate of change, 1/2. It's halving, it's going half every time. T over the half-life of this isotope. Now, 42 has nothing. It's just the name of something. You don't put 42 in the equation. All right, let's fill in our equation. Write the equation. All right, we have radioactive isotope. It's a half-life of 12.3, so that's H. Plug that in. A doctor prescribes a patient to take 500 milligrams. So A is equal to your initial amount, 500 milligrams. 1/2 to the T over 12.36. That is your equation, and you just plugged and chugged. Well, you plugged, and now you have an equation, and now you're going to chug because the question says how many milligrams, they're asking for A or Y, will remain after 7 hours. So we just plug in 7 right here. So I'm going to do it on my calculator. Y equals 500 times 0.5, 1/2, caret, parentheses, 7 divided, well, I don't want to put a 7 there, do I? I want to put an X there. X divided by 12.36. I want the equation. Whenever I'm doing Y equals, I got to have an X. Now I can graph it, or I can go to the table. Second table, and I go down to 7. What is Y when X is 7? Well, that's it. 330, we'll call it 8. Round up. 338 milligrams is our Y value. Now, this is asking the reverse question. How long, this is asking for a T or an X, will it take for there only to be 130 milligrams left? So if I were to draw this graph, I would know I'd be starting at 500. I've got a decreasing function, and the question is how long, this is Y equals 130, how long, does it take to be down to 130 milligrams? I know how to do that. 2 equations in the calculator. I already have one equation in, and I go down into Y2 and I hit Y equals 130. Then I graph that, and if I'm not seeing it, I change my table. So I go to the window. Now on the x-axis, what do I want? It's time, the hours. So let's go to 24 hours with a scale of 2. And then on the y-axis, let's go to 500 because we're starting at 500, and let's put a scale of 100, and we're going down. So now we're going to get our graph. There's our graph, and then upcoming Y equals 130. I can see the intersection, I think. Let's change that window to 26 just to make sure that the intersection is on the window. If it's not on the window, it won't graph it. It won't give you the answer. Second, calc intersect 5. Enter, enter, enter. Okay, at 24 hours, I have 130. After 24 hours, I have 130 milligrams left. So the answer is 24 hours. Okay? All right, I will see you tomorrow.